parallel versus perpendicular.
Versus or
And versus, same thing. Okay. When you think about parallel, how do you visualize that?
two straight lines.
Two straight lines that are what?
Horizontal.
They'll never cross. That's a good definition there. So basically, if we're going to do it, we're going to write the symbol as two lines like this. It could be vertical lines. Some people call it the train tracks, right? Perpendicular means they're 90 degrees to one another. Like so. When I have a slope, we're going to say 3 over 4. Okay? Meaning my first line, yeah, sorry, if you ever see a little square, that means 90 degrees. So if my first line has a slope of 3 over 4. We're going to talk a little bit more about our definition of parallel. Two lines that are parallel have identical slopes, meaning no matter whatever happens, they can never cross because they're basically two straight lines. But my second line at 0, -2 has the exact same slope. I'm still going to go up 3, 1, 2, 3, and over 4 with my rise over run. Two lines have the same slope. They lines have identical slopes. You consider them parallel. They're never going to cross. You should know this definition. It likes to show up on tests. If I have a third line, and my third line has a slope of 6 over 8, is it parallel to my first line? Why?
Because if you reduce 6 over 8.
Because 6 over 8 does reduce down to 3 over 4, which means it is the same slope. It is parallel. So please note that if the slopes are larger or even reduced, if it is the same fraction, they are still parallel. So the real trick here is when you have two perpendicular lines, because a perpendicular line is when they are 90 degrees to one another. I think we even showed that earlier on, or Maddie pointed it out. What the heck's that little square for? That indicates it's 90 degrees and they're perpendicular. So we'll start with the definition. So two lines are perpendicular when their slopes are 90 degrees to one another. We know they're 90 degrees to one another when one is the negative reciprocal of the other. So perpendicular lines will have slopes, or they have slopes, where one is the negative reciprocal of the other. We're going to kind of pause there and really talk about negative reciprocals first before we get too far into this. A couple of key things here. The term negative reciprocal. Negative, you probably understand. If you make something negative, if I have 4 and make it negative, what does it turn into?
Negative.
Hey, math. Right? Reciprocal is probably a new term for you guys. We use it in fractions quite a bit, but reciprocal is a fancy way of saying you're going to flip the numerator and denominator.
Should be a new term.
So reciprocal is basically you're going to flip the numerator with the denominator. You do it the negative reciprocal of, let's say, 8 over 11. That would turn into negative 11 over 8. That's all we're really doing to it. These two slopes, if we graph them out, will be at 90 degrees to another. You're going to have a line. It goes through the point. We'll make it easy. 1 and 1. Okay? This line has a slope of 2 over 5. I want you to graph this slope, or graph this line. I then want you to draw a line that is both parallel and an additional line that is perpendicular to it. And we said there's two, one are in parallel?
That is what?
Parallel.
Whose pens are those in the ruler? Quick question, the perpendicular of 4
Yes.
would be negative 4 or would
We start with a point 1 and 1, and we start with our slope. We're going up 2, to the right 5. Most of us should have been able to get that from yesterday's lesson. Okay? Your next one, if we're doing one that is parallel, all we have to know is the slope is the exact same. The point at which you pick doesn't really matter. So to make life easy, I'm going to pick the point negative 3, 1, 2, 3, and 2. This point right here. The slope for my parallel line is still 2 over 5. So I'm going to go up 2 and to the right 5. When I know those 2 points, graph it as nicely as possible with a marker. And we can say, hey, look, they're now parallel. The parallel lines are probably the easier questions of the two. It's the perpendicular ones that take a bit more math. So first thing you're going to ask yourself is, something that's perpendicular, we have to find the negative reciprocal of that line, or that slope, I should say. So the negative reciprocal of 2 over 5 is, if we flip it, we get 5 over 2, and we make it negative. The key here is that negative, we could have negative 5 over 2. This basically means you could have negative 5 over 2, or you could have 5 over negative 2. It doesn't matter which slope you use. Okay, whether you're going up by 2 or back by 5, and I'll show it to you when I mean that. So I'm going to start with negative 1 or a 1 and 1. Okay, the first one I'm going to use is I'm going to use negative 5 and 2. So my rise is negative 5. I'm going to go down 5, and I'm going to go to the right, positive 2. So my first line looks like this. If you had instead picked 5 over negative 2, again from 1 and 1, if I go to the right 5 and down 2, nope, rise, sorry, rise 5. 1, 2, 3, 4, 5, and my run is negative 2. 1, 2. You'll notice that your two lines will be the exact same. So it doesn't matter if you go negative 5 over 2 or negative 2 over 5. It's the same slope.
Oh, and that would be the reciprocal?
This is the reciprocal. This is basically your perpendicular line, because if we look at it with our protractor, it is exactly 90 degrees. Right? Your goal is to see if this is going to be, I'm going to give you two lines. You're going to tell me if they're parallel, perpendicular, or neither. So you have two lines. Are they parallel, perpendicular, or neither? So standard question, you're going to get 2 lines. We'll tell you the coordinates. First line is 3 and 5, 1 and 1. Your second line goes through points -2 and 6, 0 and 5. You have to show me if they're both parallel, perpendicular, or neither. The way you do this is you find the slope of the first line, find the slope of your second line, and you just look at it.
Why am I graphing?
You should not graph this.
Yeah.
Line 1. So, it doesn't matter which point you make the first or the second point, right, ladies? Paying attention. So this is going to be x1, y1. This will be x2, y2. So, y2, 1 minus 5 divided by 1 minus 3. 1 minus 5 is -4, and 1 minus 3 is -2. This turns into -4 divided by -2 is +2. If you had swapped those around, you still would have gotten +2. We're doing the same thing. This will be x1, y1, x2, y2. So y2, so 5 minus 6 divided by 0 minus -2. 5 minus 6 is -1. 0 minus -2 is the same thing as saying 0 plus 2. So we have a slope of -1 over 2. So, are they parallel? Are they the exact same? No. So we know it's not parallel. Are they perpendicular?
Yes.
How do you know? If I flip 2, I get... If I flip 2, it turns into a half, and if I make it negative, it is indeed perpendicular. Please note, you'll see a question like this on the test, or you might. Hint, hint. And if you just circle one of the 3 and give me no work at all, it's wrong. You have to show me how you got your answer. Glad you asked. Your homework is on page 349, questions 3 to 11. It's not too bad. Good luck.